Alright, in tonight's video we're going to talk about ICE charts. ICE stands for Initial, Change, and Equilibrium. Now there is a stoichiometric change in equilibrium reactions just like in regular reactions. So the amount of product formed is dependent on the mole ratio to the reactant. Okay? So, for example, we have 4 moles of HI placed in a 5-liter flask and then heated to 800 Kelvin. The system is allowed to reach equilibrium. What will be the equilibrium concentration of each species? So again, one way we know this is a different kind of problem, it's an ICE problem, is that we were not given the concentration of HI at equilibrium. Okay, it was just at the beginning, or the initial concentration. So we'll let X represent the change in concentration of hydrogen. And since we start with HI, the reaction must proceed to the right, resulting in an increase in the amount of hydrogen gas. It's going to shift to the right. Right? So again, we have to have molarity, though. So we'll calculate our molarity. And molarity is, of course, 4 moles in a 5-liter flask. Okay? So we calculate our molarity, 4 divided by 5, and we get 0.8. So HI starts off with a 0.800 molar solution. And then initially we don't have any of our products because we haven't made the shift yet. Okay, so now when we get to our change line, this is when we're going to shift. Okay, so we're going to use up some of our HI and we're going to make H and I. Okay, so we're going to make X amount of H and X amount of I because they have a 1-to-1 mole ratio. So how much HI was lost? Well, it took 2 HIs to make 1 H2. So we will lose 2 of however many H's we make, right? So again, this 2 comes from our coefficient 2. Okay, so then at equilibrium, we would have 0.8 minus 2x, x, and x. Okay, we just add them down. Okay? And then we would calculate. So we know that our equilibrium constant was 0.016. So 0.016 is equal to our concentration of our products, which are each x. So x times x is x squared over the concentration of our reactant at equilibrium. And that too has to be squared because of the coefficient. Right? So then we calculate and we find what x will be. Well, here we have x squared and a square here. So the easiest way to do that is to square root both sides. So we square root both sides and we get 0.126 equals x over 0.8 minus 2x. And then, of course, we cross multiply, combine like terms, and solve for x. So when we do that, we get, I've run out of space, so we get, I'll just do this on the back. So when I cross multiply, I get 0.1.
Just to clarify, the earlier announcement is for the men's wrestling team. They have an emergency.
And then minus 2 times 0.016.
And everyone must attend. Thank you.
To x, and that will be equal to x. Yeah, that'll be equal to x, right? And so then we want to combine our like terms, right? 0.032x and 0.101 equals 1.032x. Divide. And then we get that x is equal to 0.098. And again, that's a molarity. So that is the molarity. Again, x was the concentration of hydrogen and the concentration of iodine. Just remember, they're going to be equal to each other. They both represented x. All right, so that is our concentration. All right, so you try the practice problem. Okay, and then I will give you the answer to that problem in class tomorrow.